Okay, so today our goal is to look at straight line equations. And there's three different forms of a straight line equation: the general form, the slope-intercept form, and the point-slope form. You should be quite familiar, typically students will be familiar only with slope-intercept form. It's important that we learn to use point-slope form, particularly on this course. This one's very useful for us here. And then sometimes we're asked to give our answer in general form. So we'll have a look at that. So here's an extract from the formula sheet. Here you can see the different forms of the straight line. This one, first one is point-slope form. Sorry, the first one is slope-intercept form. So M is the slope, C is the y-intercept. We would call it slope-intercept form. This form is the one that you introduce to students first when you look at straight lines, because it's very easy to read off of a graph. If you're given a graph drawn, this is your best form to use. You can see the whole graph. But if you can't see the whole graph, or you can just see parts of it, then probably the best form is this last one here. And this one I'm going to practice using a fair bit today. This one is called point-slope form. To use this one, all you need to know is what is the slope and what is one point. And particularly if you're using a graphing calculator and using our calculator, AISL, this one can be very useful and very easy to use. Some questions will ask you to express the answer in general form. This is called the general form of the straight line equation, because this form of an equation allows you to draw vertical lines. It allows you to draw vertical lines. You can't draw vertical lines with the other two, because the slope is infinite. So it doesn't work on the other two, but it does work on the general form. Let's have a look at the question. So our first question says, find the equation of a line that has gradient 3. So we're given the gradient. This passes through the point A, which is at 1, 7. So it's very easy to insert this one into the point-slope form. So here on this one, we have the form of the point-slope form. Y minus y1 is equal to m bracket x minus x1. I want you to practice using this one. If a question says give the equation of a straight line, you can leave it in this form. This is an equation of a straight line. So we're given a coordinate. So this coordinate here would be your x1 and your y1. x1, comma, y1. This is a particular point. The y and the x in the formula that don't have the subscript are the general y and x that create the equation and allow it to vary. And then m we know is slope. So we can put the values in. This is going to be y minus 7 is equal to 3 bracket x minus 1. So at this point, we have answered a question, find the equation of a straight line with this information. So in this question, we are asked to draw on the graphing calculator. Take out your graphing calculator at this point. Let's have a look at how we use the graphing calculator. Typically, when I start with the calculator, I like to start by pressing on, and then 1 for new, and then say no to the document, and always add a calculator page. Always when you start like this. In this question, we're asked to draw it on our graphing calculator. So we're going to press Control, add page. You can find them here and here. You see it on my screen where it lights up red. That's where I'm pressing. Add graph. You can't type y minus 7 into this. You always have to do a bit of a rearrangement. So in order to draw it into your calculator, we don't have to expand it and rearrange it into slope-intercept form, but we do need to algebraically move that 7 across to the other side using inverse operations. So this will give us 3 times bracket x minus 1 close bracket plus 7. We press enter, and we see how the graphing calculator, how it looks on the graph. Make sure you have a go at drawing that successfully. Great, so our next question. Find the equation of a straight line that passes through A, 1, 3, B in point gradient form or point slope form, and draw the graph on the axes. Okay, so what I'd like you to do is to have a go, start using the same technique that we used here. Start by finding the gradient, then use this form, use the point slope form. Once you've done that, expand the brackets until we get it into slope intercept form, and then you can graph. Have a go with this question, we come around and have a look. Okay, so for this one, we need to start by finding the gradient. I think this gradient is fairly easy to find. So the gradient we can always do is the change in y values over the change in x values. So as we go from the A to B, how much do the y values change? It goes up by 2. As we go from A to B, how much do the x values change? They go up by 1. The gradient here is 2. We need to enter this in point slope form, and we're given 2 points. So we can choose, it doesn't matter which one to use for this. If there's a 0 in one, use that one, so 0 is a lovely number. Otherwise, I'll use one with a 1 in it. So we are going to have y minus 3 is equal to 2 bracket x minus 1. And we're asked to give the correct answer in point slope form, and then we're asked to draw it. So if you're converting from this to draw the graph, there is a strategy you can use. Any point on the coordinate axes has either the x value is 0 or the y value is 0. So try this technique. Let me just show you. What I'm going to do is I'm going to start by entering x as 0 into the equation. So if I enter x as 0, I get y minus 3 is equal to 2 bracket 0 minus 1. So 2 times minus 1 is going to give us minus 2. Y minus 3, and then move that 3 across. That gives us y is equal to 1. So when x is equal to 0, y is equal to 1, it's going to go through here. I'm going to do the same for the y value. So if I make y, which one am I doing? If I make y 0, enter a 0 in here this time, 0 minus 3 is equal to 2 bracket x minus 1. This, expand the bracket, we're going to get 2x minus 2 is equal to minus 3. And then we move this across. This gives us, we add 2 to both sides, we get minus 1 is equal to 2x. X is equal to minus a half. So then we can plot that point. So when y is equal to 0, x is equal to minus a half, the graph is going to go like this.
So isn't there an easier way?
Sorry?
Isn't there an easier way?
There is.
You just get y equals mx plus c and put the c as the y-intercept.
There is, yeah. I don't think this turned out the easiest. Sometimes it does.
It's much more complicated.
It was, you're right. What I would probably do for you guys is, so our question finished here at this point. And what you can do is you can expand the bracket, you're going to get in slope intercept form, and on this one, it's going to come out quite easy. This technique didn't come out easy this time, sometimes it does. It's going to give us y is equal to 2x plus 1. So we can draw a point here. We go up by 2 every time as we go across, it goes like this. And we're going to get a straight line. Alright, sorry. I showed the wrong technique at the wrong point. This is the technique. This is the question where you want to put the zeros in each time. What was I doing? That was awful.
This you just put in your calculator.
You try and put it into your calculator. It's not so easy. But let me try it this time. I'm going to put in 3, I'm going to put in 0 here. Plus 6y is equal to 12. I'm going to get 6y equals 12. Y equals 2. I'm going to try again for the other one. 3x plus 6. Put in a 0 this time. Equals 12. 3x equals 12. X equals 4. Sorry. So this one is going to go through 0, 2, and it's going to go through 4, 0. You draw a straight line through that.
So to find each coordinate, you're always subbing in x and y for 0?
On this form, sorry.
So I just have a question for the last question on the x coordinate is -1/2 of 1. I just need to plot those 2 points and then just connect them.
Yeah. All right. So a little investigation using a graphing calculator. Find the x and y intercept of the following lines. Work together in pairs on this one. Okay. So I'm going to look at some calculator tricks now in order to find different bits and pieces of information from these questions using our graphing calculator. So what I want to do on this one is I'm going to just add a page. I'm going to add a new graph page. I'm going to graph the second one. We've got y equals 3x plus 4. Like this. So I've entered it into the graphing calculator. I'm going to show you a couple of techniques that will be useful for us on this one. We need to find the axes intercepts. So if I want to find the y-intercept, I can read it off. For this one you would need trace, number 5. So follow me along on your calculator if you are. Follow me along. We can use trace graph. For this what we have to do is we press 0. We want x equal to 0 and then press enter twice. And you will get the x coordinate here for the x and y coordinate for this one. So this one goes through, our y-intercept is 0, 4. The x-intercept would be where it crosses the x-axis, that would be the 0. So the technique would be menu 6, analyze graph, and then find the 0. You get asked where is the lower bound, where is the upper bound. So we scroll this across, press, scroll it across to the other side, and press, and we see that it comes at minus 1.33, 0. Let's have a look at the second one. So the second one, I can't draw this one without rearranging and expanding. I can do that technique, but let me show you some other techniques. Is I can scroll over to the calculator page and I can use nsolve. So menu, algebra, nsolve. I can type the equation in, and each time I can change this into being 0 plus 8y minus 17 equals 0, comma. And here in nsolve, after the comma, you're saying what to solve, what variable to solve for. There's actually 4 parameters you can pass. The first parameter is the equation. The second is the variable. And then you can add bounds that we will see later in the topic 3. Add bounds. So what I'm going to do is I'm going to solve for the variable y. And we get this one. If it looks like this and I want to see it as a fraction, you can press menu number 2. Approximate to fraction, 17 over 8. So this is going to go, when x is 0, the y value is 17 over 8. You can always have an answer as a fraction. It's more exact. I can go up to my technique that I'd used. I'm just scrolling up, copy it down. I can go in here and change that 0 back to being Sorry, sometimes on my board, it just auto repeats and just keeps deleting. Let me try it
How
again.
did you get the structure?
Menu 2.2. So I'm just changing the x and y values. Oops, I got an error because I didn't change what variable I'm supposed to be solving for. And here on this one, I'm going to solve now for x. And we get 8.5. So this goes through 8.5, comma 0.
And basically, to find the y, just plug in 0.
Yeah. So either of those two techniques would work for this third one. I'm just going to add a new page, add a new graph. I'm going to graph this one. Remember that we have to move the y to the other side to graph this one. So I've got to enter it in looking like this. Let me see if I can show more strategies, if I can think of anything else to do. So I'm pressing Control Divide and I get the quotient. Allows me to enter in the fraction a quarter like this. I open up a bracket, I get x plus 5, close bracket, plus 3, as I've moved that 3 to the side now. I get the graph drawn. If I want to find this one, let me show another strategy for finding. So I showed you how to trace when x is equal to 0. I can also go to the calculator page. This one that I just put in, ooh, my AC's coming. This one I just put in, I put it in as F3. So if I come here and I press this variables button, this is really useful. Look above the 9. Above the 9, it pulls up the different graphs, and we can enter values into this one. So we can do f of 3 is equal to 0, and it will tell us the answer. So the x-intercept for this one is going to be at 0, 17 over 4.
Wait, can you repeat how you were the x?
I think it's started from 12.
And then the variable.
That's like effectively.
And then
And then what's that?
All right, so I want another strategy. We want the function is equal to 0. So another strategy I could use is I can use nsolve, menu, algebra, nsolve. And we want when function 3, when defined over the variable x, is going to equal 0. And I want to solve for x. So I can put this into the calculator, and this is going to give me the x-intercept, which is, sorry, I'm writing this the wrong round up. This is the y-intercept, this is the x-intercept. This is when y is equal to 0 and x is equal to negative 17. Okay, where are we now? Okay, bit of problem solving question. Have a go at this one, 5 minutes to work through. This is typical of an exam style question. Does it have a sign?
Every single month on the same day.
Sorry, let me pause the video. So if you're watching the video at home, at this point pause the video and work on the question yourself for a few minutes before watching the answer. Okay, so what we want here for this one is an equation system. When it comes to writing it on your notes, if you're writing in an exam, the technique that we're about to use, you have to write the two equations like this, one under the other, and then make a system of equations using the single curly bracket like this. So this will imply our solution. What we can then do, we can use the graphing calculator to do the work for us, and we're going to enter in exactly that we see there onto the graphing calculator. When it comes to this strategy, you can enter the equations in any form. We're trying to find the intersection of the two. So this is one of the key, most useful tools, this one. I've shown a lot of examples, I've shown a lot of bits and pieces. Obviously, graphing is really important, using nsolve is really important. This particular strategy is also very important. we're going to go to menu, algebra, and then system of linear equations, number 2, system of linear equations. Find that one now on your calculators. We click system of linear equations, and it says how many equations do you have and what variables would you like to use. So 2 and x is the default. So it pops up a linear equation solver, and you see the curly bracket. We can enter this in now. You don't have to rearrange them into y equals. We can enter them like this. Well, they are already rearranged. We enter them like this. And then we can say y equals minus 2x plus 5. So once you've typed the equations in like this, simply press enter, and it will give you the coordinate of the intersection. You should enter that with a round bracket, not a curly bracket. This is at minus 2,9. So this is the coordinate of the intersection point of the two roads. Graphically, what we can do graphically is to get a visualization of how this one looks. We would have to enter the two functions in, 3x plus 15, and then we press tab to put in an extra equation onto the same graph, minus 2x plus 5. We can't see the intersection point because it's up here at the top. We already know the answer is 9, so we need to go a little higher. To adjust one of the coordinate axes, notice how it tells you, this is the standard setting where it goes from negative 10 to 10, negative 6 2/3 to 6 2/3. Double click on one of these, and you can type over it and change it. So I'll change this one to 15. We'll see how the graphs look now, and we can find the point of intersection using analyze graph. We can find the intersection. We have this lower bound, upper bound strategy. So you have to go to the left of where it occurs, press enter, and then we go to the right of where it occurs, press enter. And it will give us the point of intersection. Practice using your calculator a lot. You get quicker at doing it, you get more familiar with the routines. So take the time to use your calculator, use some of the strategies presented here today. Okay, our last task is to work together in pairs on this investigation. We have 10 minutes for this one, so pause the video at home and have a work through it. Alright, so Bike and Bloom sells flower bouquets. The equation modeling the total cost C of making a number of bouquets, X is given by C equals 6,000 plus 72X, where C is given in Danish krona. Find the gradient of the line representing the equation. So the gradient is going to be m equals 72. That's pretty straightforward, that is. Interpret the meaning of the gradient. So when it comes to interpretation questions on this course, you have to give an explanation in context. So some of these can be the most challenging questions that we get, is interpreting or giving a real. So you have to step back a little bit from the math. So we're looking about the sale of bouquets. So the cost of making a number of bouquets is given. So what is the gradient in terms of the context? What does the gradient represent? How much does it cost to make one bouquet? Yeah, that's what it means. So it costs 72 danska kungliga krona. 72. My two's not looking very good. 72 Danish crowns to make one bouquet. That's what it means. Determine the y-intercept. What did we have for the y-intercept? So the y-intercept is at 0,6,000. Could the total cost per month be 0 if no bouquets are made? No. No. That's leading us into why?
Because when x is 0, y is 6,000.
The total cost in a certain month is 112,720. Draw a line on the same axis of the graph, the line representing the cost, the equation modeling the equation, and then find the number of bouquets that were made. So we have to do an equation system here for this one. I'm just going to freshen up my workspace, start with a new one again, because I know I always had a calculator page, I'm going to add a graph page to this one. We're going to have a graph page. We need to add the two, we need to have the line representing the cost. So to represent a line at a particular value, we do 1, 1, 2, 7, 2, 0. So just enter the number in like this, we'll draw the line, and then we have to enter in the equation, so we press tab, enter in a second equation. This equation was, where is it? It's there, 6,000 plus 72x. Okay, it's not drawn anything. Why? Yeah, it's zoomed in. Our number here is at 112,000. So we need to have much, much bigger axes. We need to have much, much bigger axes. So go to this value here at the top. Always go above the value that we're looking for. So let's go to, let's say 130,000. So 130, 1, 2, 3. 130,000. Now we can start to see the two lines, but they don't cross. Why don't they cross? Because this red line is actually going up, but it's going up at a slower rate. So we need to make this value here on the x a lot bigger. If you can't get it to, like at the moment I'm trying to click on it and it's getting that line instead, I can't get it. You can always get at these values by going menu, window, and then window settings. So here in the window settings, we want the x maximum to be something a lot bigger. So I can press tab to move around. And let's go up to 10,000 or so. See how it looks. So put in 10,000. Oh, now we can see the two lines cross. So we've drawn the graph, and we need to find the number of bouquets made. So we need to find the intersection of these two. I'm going to analyze the graph, choose intersect, scroll backward, click here, click there. Look at the number here. So what do we have there? What is our x value going to be? It's going to be 1.48 times 10 to the 3. We can put that in like that. If we want to write that in as a number, let me see if it'll give me it here. 1.48 E3. And then I see the number. That is 1,480. Sorry, I have my calculator set for my AP class. Let me just change that. So document 7.2, we're going to change to float 3 or float. This one, I think. Okay, so to finish today, we need to work with these questions from the textbook. At the moment, the AISL links are not set up. Hopefully, we were told that we'd start working this week. So you can click on the AISL and start using them, but I'll let you know once it is working or just click on them.
So which equation should